Hello P5 and P7, how are you guys? I hope you're having a good Friday. I'm sorry I'm not with you today, but I will be back next week. As I told you on Wednesday, your job today is to complete notes with me in your notebook and then to do a practice packet. So Miss Calvert is here. She can answer questions for you. My substitute can hopefully answer some questions for you. And yeah, it shouldn't be too difficult, okay? So just follow along with me as I write. You can pause the video when you need to. You can, if Miss Calvert's able to put this up on the big screen, you can ask questions. Even if she's not, you can always, if you're listening to it by yourself, you can pause the video and call her over to ask her a question if something is not making sense, okay? So on Wednesday, we just did a quick little coordinate plane review. We talked about the parts of the coordinate plane, ordered pairs. We talked about how to locate the coordinates of points. We talked about the quadrants, and we talked briefly about discrete graph and continuous graph. And today we're going to switch gears and we're going to talk about relations. So if you turn to page 14 here, we're going to talk about relations and then how to tell if a relation is a function, okay? A relation is just a set of ordered pairs. So if you have some space right here, oh, actually there's a line right here, definition, there we go. A relation is just a set of ordered pairs. And remember, ordered pairs is the, parentheses with two numbers separated by a comma, like these, for example. This is a relation, a set of ordered pairs, okay? And you can show relations in 4 different ways. That's the main thing for you to know about this page, is the 4 ways to show a relation. You can show them as ordered pairs, a set of ordered pairs. And notice that each ordered pair, in between them, there's a comma to separate them. And then at the beginning and the end, there are braces. That's how you show that they go together, that they're a set. You can also show them in a table. You can show them in something we call a map. And you can show them on a graph. So we're going to take our relations and we're going to represent them in the 4 different ways. So here's our first set of ordered pairs. And by the way, we're going to skip this part right here and we're going to skip where it says domain and range. We'll come back to that later. This first set of ordered pairs, remember that in any set of ordered pairs, the first number is X and the second number is Y. So if you have a set of ordered pairs written like this and you want them to put in a table, you just take the 2 numbers and you write them next to each other like this. So for -3, 1, I would list this like this, -3, 1. -2, 0, be -2, 0. 1, 2 would be 1, 2. 3, -4 would be like that. And -3, 5 would be like that. Okay, so it's very easy to take your list of ordered pairs and create a table. Now, when you are going to make your map, you need to make sure that you're not repeating any X values. Notice that in my ordered pairs, I have 2 separate points that start with -3 as an X value. When I put those numbers into my map, I'm only going to list that once, okay? So what I'm going to do is, the map is these 2 ovals. The first one is X and the second one is Y. So I'm going to list my X's and I'm going to make sure I don't repeat any. So -3, -2, 1, and 3. I'm not going to put this -3 because I already have one, okay? So in the map, this is called a map, you do not repeat X values. Let's put a little note over here. Do not repeat X values on the map. Okay? Take a moment and write that in. Actually, put or y values, because honestly, you're not going to repeat any y's either. So on the y side, I'm going to go back to my table. I'm going to put 1, 0, 2, -4, and 5. Since I didn't have any that repeated, I needed to put them all. All right. Now to finish the map, what you do is you draw arrows to show which x value goes with which y value. So we start back at the top here. -3 goes to 1. So we're going to draw an arrow straight across like that, from -3 to 1. -2 goes to 0. So we're going to go from -2 straight across to 0. One goes to 2. So that's going to connect like this. Three goes to -4. And then -3 goes to another number. It went to 1 already, but it also goes to 5. So we're going to go back to where -3 is, and right here where I drew my first arrow, I'm going to start a second arrow, and it's going to go like this. So we're showing that -3 has 2 different y values. All of the other x's only have 1 y value. Okay? Then, if I want to show my relation by a graph, I can go back to my ordered pairs. Remember that the first number tells you to go side to side, and the second number tells you up and down. So -3 means start at the origin and go to the left 3, and then +1, go up 1. So there's a point. The second one is -2, 0, so go back to the origin. Since it's -2, we'll go left 2, and then 0 means don't go up or down at all. So our dot is going to be right here on the y-axis. Our third one is +1, +2. So this time I'm going to go to the right 1, because it's positive, and up 2. Then I'm going to go 3, -4, so starting at the origin, 3 to the right, and 4 down. And then my last dot is -3, 5, so I have to go -3 again, 1, 2, 3, but this time I'm going up 5. 1, 2, 3, 4, 5. So all 4 of these boxes represent the same information, the same data. You have 5 ordered pairs. You have those 5 ordered pairs in a table. You have those 5 ordered pairs in a map. And you have those 5 ordered pairs represented as dots. Okay. Now we're going to look at the second one. So again, here are my ordered pairs, and I'm just going to transfer each one over here to the table. So -2, -3, -1, 4, 0, -2, 2, -4, and 5, -1. All right, so there's my table done. Now for my map, I'm going to list my x values, and if I look at the list here, none of them are repeated, so I need to fit all 5 of these in this oval. So -2, -1, 0, 2, 5. And my y values, if I look at these, also none of these are repeated. I've got 4 and -4, but that's 2 different numbers, right? So I'm going to start at the top and I'm going to fit all 5 of these in here. -3, 4, -2, -4, -1. And to finish the map, you draw your arrows to connect them. And since none of these are repeated, they're all just going to go straight across. -2 goes to -3. -1 goes to 4. 0 goes to -2. 2 goes to -4. And 5 goes to -1. And to put these on our graph, -2, -3, so we're going to go left and down because these are both negatives. So left 2, down 3. Second point is -1, +4. So left 1, up 4, because it's positive. Third dot, 0, -2. 0 means don't go side to side at all, just go down 2. We're going to be right there on the y-axis. 2, -4. We're going to go right 2 because it's positive, down 4 because it's negative. And 5, -1, over 5, down 1, right there. And that is number 2 done. And let's do number 3. Now for number 3, they didn't give us the points, but they did give us the graph. So we need to write the points ourselves. So remember that when you start to write your relation as ordered pairs, you need to start with a brace. That's that thing that kind of looks like the curly parentheses. And we're going to go from left to right on our graph. So the first dot I'm going to look at is this one right down here. Here's the origin. In order to get to this dot, I have to go left 1, 2, 3, 4, 5. So that's -5. And then from here I have to go down 1, 2, 3, 4. So that's -4. So you have that in parentheses with your comma in between, and then you put another comma before we do the next point. You can go ahead and put your parentheses there if you want. So the next point is going to be this one now, because I'm moving from left to right. So to get to this dot, if I start at the origin, I have to go left 2, so that's -2, and then up 3, +3. -2, +3. Put a comma and another parentheses. Our next dot is going to be this one that's on the y-axis. So here's the origin. I don't need to go side to side at all, so that first number is going to be 0, but I do have to go down 3. So it would be 0, -3. Another comma, because we have 2 more dots to go. We'll put those underneath here. So our next one is this guy right here. So from the origin, I have to go over 2 to get right above it. So that's +2. And then 1, 2, 3, 4, 5 down. That would be -5. So +2, -5. And then we'll have one more dot, which is this last one here. So from the origin, I go over 1, 2, 3, 4. That's +4. And then up 2. So 4, 2. And then after your closing parenthesis, or parenthesis, I guess, that's the singular, put your brace on the other end. Now that we have that, we can create our table. So our first dot, -5, -4. Second one, -2, 3. Third one, 0, -3. Fourth one, 2, -5. Fifth one, 4, 2. For our map, I'm going to check my x values. These are all different, so I know I need to keep them all. So -5, -2, 0, 2, 4. My y values are also -4, they're all there, -4, 3, -3, -5, 2, and they're all going to match up evenly. Now sometimes, guys, I've seen some people do these maps where the x and y values are from like least to greatest, top to bottom, which these are not. Well, this one is, but this one is not. I have to sorry, I had to sneeze. But then I've seen other places where they don't put them least to greatest. So I don't know if that's actually a requirement, to be honest with you. You're not going to have an SOL question where you have to make the map. You might have to choose which map would be correct. And as long as the correct values are there, you're going to be fine. I actually doubt that you would even have that as a SOL question too. I never see that come up, okay? But that is how you represent your relations in 4 different ways. Set of ordered pairs, table, map, and points. And remember that these graphs that have only dots on them are called discrete graphs. If you have any questions about this page, you can pause the video and ask Miss Calvert. I am going to flip over now to page 15. And now we're going to talk about what makes a relation a function, okay? What makes a relation a function? And I am looking for my page real quick here. So a set of ordered pairs, a relationship, right? Or a set of ordered pairs or a table or the maps, we know that these are relations. But sometimes they're functions and sometimes they're not. So the question is, well, how does it become a function? Well, first of all, what is a function? I'm going to put the definition here and then you can pause it to copy, okay? A function is a special relationship between values, semicolon, where each input, or x, has exactly one output, or y. All right, go ahead and hit pause and take a moment to copy that sentence down. Okay, so looking at, we were talking about a set of ordered pairs. Every x can only have one y. So an x value can't have 2 different y values. It has to only have one value, y value. So here's an example of a function. Put your brace, and I'm going to give you 4 points here. 0, 6, 5, -2, 7, 9, and 11, -1. Go ahead and pause again so you can get that written down. Okay, so if you look at these ordered pairs, look at the x value. I have 0, 5, 7, and 11. None of these repeat. If none of the x's repeat, then you automatically can say, yes, it is a function. Okay? If none of the x values, so that's the 0, the 5, the 7, and the 11, if none of those repeat, then you know that it's a function. If any of those values do repeat, then you need to check the y's and see if the y's are the same or different. So here's an example of what would make something not a function. You got another brace here. We're going to have 4 more points. -4, comma 1, -1, comma 7, -1, comma -2, and 5, comma 6. And you can pause and take a moment to write all that down. All right, so now if we look at these ordered pairs, I notice that 2 of them have -1 in the x position. So I'm going to circle those 2 points. Well, if they have the same x value, I need to look at the y values. These y values are different. This -1 has 7, but this -1 has -2. And we said that to make it a function, every input or every x only has one y. Well, this x, -1, has 2 different y's. It's got 7 and it's got -2. So that's what makes this not a function. You're going to look at your x values to see if any repeat, and then you're going to check the y's. If one point was in here twice, like -1, 7, -1, 7, that would be fine. But if it's -1, 7 and -1, -2, the 2 different y values make this not a function. Okay? So I think it'll be easier to understand if we just do a whole bunch together here. So these say determine whether the given relation is a function. So take a look at these points, and we're looking to see if we have any repeating x values. I have 5, 3, 2, 0, and -1. Those x's are all different, so yes, this is a function. Take a look at number 2. I have -2, 0, 2, 3, and 2 again. So I've got 2 points that have the same x. I'm going to circle those. Now look at the y's. I have -4, +4. That's 2 different numbers. And a function is not allowed to have the same x with different y's. So for this one, we have to say no, not a function. For number 3, look at your x's. We have -4, -3, -2, 1, and -3 again. I've got 2 that start with -3 as the x. So I'm going to circle those 2 points, and then I'm going to check the y's. My y's are different, -1 and 2. If you have the same x with different y's, that means no, not a function. And on number 4, check my x's. I have 1, 2, 3, 4, and 5. All the x's are different, so this is an automatic yes. Okay, hopefully that made it a little bit easier to see what I'm talking about. And we're going to do the same thing with the rest of the page. Remember, this is the same information, just in different forms. So now, with the table, I'm going to do the same thing. I'm going to check my x values and see if any repeat. I have 3, -1, 0, 2, and 3. So I do have repeater right here, because they both have 3 in the x column. When I look at the y's, these are 2 different numbers. So is that a yes or a no? That is a no, not a function. Excuse me. All right, take a look at number 6. Look at your x column. -4, -2, 1, 2, and 5. If all the x's are different, what does that mean? That means yes, it is a function. Number 7, check your x's. -5, -3, 0, 1, 2. They're all different, so that means yes, we have a function. Looking at number 8, I have 1, 4, -7, 4, -1. I've got 2 4s, so I'm going to circle those points, and I'm going to check the y's. My y's are not the same. That means no, not a function. Number 9, in my x column, I have -8, -4, 0, 4, +8. These are all different, so I can say yes, this is a function. Now, some people say, but Miss Bryant, the y's, what about all these y's are repeated? That doesn't matter. You can repeat the y's all you want. What matters is if you repeat the x's, then you have to check the y. And if the y's were the same, then you could say yes. But if you have same x, different y, that's when you have to say no. So that's why we always check the x column first. And if these are all different, I don't care what the y column is. Okay? Number 10, I have 1, 2, 3, 4, 5 down my x column. These numbers are all different. That means yes, I have a function. And we can do the same thing with our map, but with the map, you're going to look at the arrows. Every x should only point to one y. So -3 points to one number, -1 points to one number, 2 points to one number, and 4 points to one number. Even though the -1 and the 4 both point to 4, remember, it's okay if they have the same y. It's not okay if they had the same x. So if you, again, look at your x's, the x's are all different, so this is yes, this is a function. For number 12, though, look at your x column. -4 only points to 4, but look at -1. It points to -1, and it also points to 7. One x number is not allowed to point to 2 y numbers. So this is no, not a function. And let's check number 13. -1 only points to 2, 0 only points to 1, 1 only points to 2, and 2 only points to 5. So our x's all just have one arrow off of them, so we can say yes, this is a function. Okay, so that's how you tell if you have a function when you're given the ordered pairs in either a list like this, or a table, or a map. You check the x's. Let's put something right, actually, let's put it right over here. We can write these steps. Check the x's. If all different, it is a function. I'm going to give you time to copy this in a second. If repeated, check y's. If y's are different, not a function. All right, take a moment, click pause, and take a second to jot all of that down, and then I'll meet you on the next page. Okay, so we talked about what happens when you have your points listed out for you and you have the x and the y listed, but what happens if you have the graph like these? How can you tell if it's a function or not? We use something called the vertical line test. And the vertical line test is this. I'm going to write this and then give you time. If a vertical line, and remember vertical means straight up and down, intersects a graph more than once, then it is not a function. All right, pause the video and go ahead and copy that down. All right, so here's an example. I'm going to make myself a little baby coordinate plane, and I'm going to put a straight line on it like this. All right, take a second and copy that picture. You can hit pause. Okay, imagine that I'm going to take my pencil and I'm going to go across this graph left to right until I run into that orange line. How many places am I touching that orange line? Just once? Just once? Just once? Just one spot? Just one spot? Just one spot. What you're doing is you're looking to see, as your pen comes across, the orange line is only hitting the pen in one place. Here, the orange line is only hitting the pen in one place. Here, the orange line only hits the pen in one place. That makes this line a function. An example of what would not be a function, I'm going to draw another baby number line, and this time I'm going to put a circle on the graph. You can pause and take a moment to draw yourself one. Okay, if I come across with my pen right here at the very edge of the circle, I'm only touching the pen in one spot. But as soon as I move it a little closer, do you see how my orange line, my orange circle is hitting the pen at the top and at the bottom? That's two spots at once, right? Two spots at the same time. If I come over here, again, I'm hitting two spots at the same time. If I slide a little further, two spots at the same time. That makes it not a function, okay? So you want to imagine, and you can actually use your pen to go across and see, am I hitting it just once or am I hitting it twice or more? If it's once, it's a function. If it's multiple times, it's not a function. So let's take a look at these examples. Here's a discrete graph. I'm going to put my pen on the left and I'm going to slide over until I touch the first dot. And when I touch the first dot, what do I notice? I'm actually touching two dots at the same time, right? My pen is going to hit both of those dots at the same time. Well, if I hit two places at once, remember that means not a function. All right, take a look at number 15. I'm going to start on the left side. As I come across, I hit one dot, keep going, one dot, keep going, one dot, keep going, one dot, keep going, one dot. Every time I hit a dot, it was just once, one dot. So if I hit one dot at a time, this is a function. All right, take a look at this graph that has a line on it. Again, just like our example, if I bring my pen across, right here, my line is only touching the pen in one place. If I move it here, I'm only touching in this spot. If I move here, I'm only touching in that spot. If I move here, I'm only touching in that spot. My pen is only ever touching my line in this one place. So this is a function. All right, look at number 17. If I start on the left and bring my pen in, right from the jump, I'm hitting this shape on the graph is touching in two places, at the top and the bottom. 2 places, 2 places, 2 places, 2 places, and that's not allowed. So if you're touching in more than one spot, not a function. We already know from our example that the circle is not a function, because as soon as I come in a little bit, I'm touching, the circle's touching here, but it's also touching here. Same thing over on this side. It's touching at the top and touching at the bottom. So this is not a function. Number 19, if I drag my pen over, right here I've got touching in one spot, come over further, touching right there, one spot, up at the top, touching right there, one spot, keep going, touching right there, one spot, touching right there, one spot. So no matter where I put my pen, I'm only touching this line in one place, so this is a function. And finally, our last two. I've got a vertical line right here, and if I drag my pen over, boom, I'm touching the entire line at once. My pen is touching in a million spots. That is no, no, no. This is not a function. And think about number 21. I'm going to pull my pen across slowly. Think about how many places, every time I stop, how many places is that line touching my pen? If you said this was a function, you are correct. No matter where I stop my pen, I can put it anywhere, that line is only hitting my pen in one place. Over here, it's hitting down here, right here, it's hitting up here, over here, it's hitting right here, only over one spot. So that is a function, okay? If you have any questions or issues, please feel free to ask Ms. Calvert or my sub. Basically, your job now is going to be to identify functions. You're going to have a packet, and in your packet, you're going to have to look at points and decide if it is or is not. You're going to have to look at tables, decide if it is or is not. You got to look at maps, decide if it is or is not. And then you need to look at graphs and decide if it is or is not. As always, I'll have the answer key out on my desk for the sub to show you so that you can check your answers as you go. You should probably do one section at a time. Do this part and check it, and then do this part, and then do this part, and then do this part. And if you're getting them right, you're doing pretty good. If you find that you're making some errors, take a minute and talk to Ms. Calvert or talk to one of your friends who seems to understand it pretty well and see if maybe they can help you. Maybe they can word it a little bit differently to help you understand it. Make sure your name is on the packet that you get, because I'm going to want you to turn that in at the end of class. You should be able to do it very quickly. I'm going to show you what it looks like. So you have right here, all right, you have your ordered pairs, and you're just going to say, you know, function or not a function. You've got some discrete graphs here, so you're going to use that vertical line test. Here you have a page of tables, so remember, look at your X values and then look to see if there are any repeated ones. Then here you have a whole bunch of maps. Remember, you're looking for those X's should only be pointing to one number. If it points to two numbers like this one, wah wah, that's no good. And then finally on the back, you have some continuous graphs. You're going to use that vertical line test again. Okay, this is it. If you finish this, go ahead and turn it in. Make sure your name is on it. It's not for a grade, but I do want to check and see how you did. So make sure you turn this in whether it's done or not. If you finish this and you're looking for something else to do, you can work on the pumpkin graph that we started on Wednesday, or you could do your homework. Homework number 10, first grade of the marking period, is due today. All right, guys, I hope everything goes well. I hope you guys have a great weekend, and I will see you next week. Bye-bye.